Hello world! We have already talked about positioning and styling in Fluent UI React v9. Now let's explore the foundation of the UI library. There are three key low-level APIs in Fluent UI React v9 that you will see sooner or later: slots, JSX children, and triggers. Let's start with slots.
The first appearance of the Slots API was in Semantic UI React. Its intention was to provide a predictable way to customize parts of a component. With plain HTML, this is not a problem. We have explicit access to the whole code snippet, and we can customize every part of that snippet, but with reusable components in a UI library, such as Semantic UI React, we have a different goal. We want to build components that can be reused and hide this HTML inside the component. Nonetheless, reusability doesn't change the requirement. Consumers do want to customize the structure of the HTML, passing additional attributes, changing styles, or removing parts of the snippet. Let's take a second to explore the anatomy of a button component, for example. It may have a content, icons, before and after the content, and it might be wrapped in a container. Every UI library wants to meet this reusability requirement. For example, before the introduction of the Slots API, Fluent UI v8 tried to solve this problem by exposing properties such as button props, icon props, and render functions to customize the internal parts of a component. The problem with Fluent UI v8 approach was the lack of consistency. Some parts of a given component anatomy weren't exposed, and what is worse, the signature of how a part of a component would be accessed could change from one component to another. You couldn't follow a learn once approach for the whole library. So, what's different in Semantic UI React Slots API? The initial goal was to provide a consistent experience, covered by conformance tests that are used to validate every component. A component that needed to expose part of its internal markup would have a slot. Inspired by CSS notion of shorthands and longhands, we introduced the shorthand version of a slot. The shorthand is used for the case of passing only content, since it was the most common scenario. Meanwhile, if modifications to properties of a slot were required, then the more verbose longhand version could be used, allowing modification of properties and content at the same time. Some exceptions for the shorthand as content were introduced in some slots for convenience though. For example, the avatar component has an image slot. If a shorthand is provided to this slot, it will be interpreted as the source property. Since image doesn't support content, that simplified the usage of that slot, although creating some inconsistencies with other slots, since sometimes shorthands would represent content, and in this case, it will represent a property. The Semantic UI React Slots API provides a consistent way to customize a component, allowing content and properties of internal parts of a component to be exposed. On another subject, there is a problem about how to replace a slot entirely. This problem was not solved, and as in Fluent UI v8, render functions were defined to address this. This concludes the story about Semantic UI React Slots API. Let's call it Slots v1. When we started to work on Stardust UI React, we started it as a fork of Semantic UI React. The APIs were the same, but with increased adoptions in teams, we got more and more feedback from our partners. The existing API had benefits, but it also had problems. One of them was the not-so-obvious behavior of shorthands. When a string is passed, it renders the default element, and the string becomes child content of that element. But when a JSX element is passed, it replaced the default element entirely. The main change we made was to normalize this behavior and ensure primitive values, such as string and JSX element, are handled the same way to ensure consistency. Another issue we had was the replacement of base elements in slots. For that, we introduced a new API following the idea of render props. With this API, partners can pass a function as the children prop of a slot and replace or wrap the existing element. This is especially useful for cases with tooltips, for example. This sums up Stardust UI React Slots API. Let's call it Slots v2. During convergence from Fluent UI v8 and v0 into Fluent UI v9, we picked things that work well and try to improve them. The Slots API that we had in Stardust UI React was a good candidate. It allowed users to tweak components anatomy in a consistent way, However, there was some room for improvement. In Fluent UI v9 Slots API, all shorthands are resolved to children. And for slots like image and avatar component, shorthands cannot be used at all, since they are void elements and don't accept children. The interesting part is that while idea-wise slots are closer to Stardust UI, implementation-wise you can easily find its roots in Office UI Fabric. Office UI Fabric introduced the concept of slots quite early on, due to different necessities provided by our partners. The implementation happened naturally on a case-by-case basis for each component. The result was a collection of different ideas that together formed the concept of shorthands that we now use in Fluent UI v9. Even though the pattern was not so consistent across the library, it laid the foundation for Fluent UI v9. We've combined both separate ideas into the current shorthand API that is consistent across the entire Fluent UI v9 library.
This is my favorite part. We started with a great idea, but it crashed on the metaphorical rocks of large application usage. However, we learned a lot of great things that we can share with you. There are different approaches to split UI components into logical groups. For simplicity, in this example, I will stick to two main groups: elements and collections. How did we come up with these groups? Elements are self-dependent, for example, a button and a checkbox, while collections have a host component and child items, for example, a menu and menu items. And it's time for the most valuable question: how to define such collection from API standpoint in JSX markup. First, in Semantic UI React and then in Stardust UI React, we went with what we called Collections API. To define a set of items, we used an array where items are shorthands. The API looks great and simple in documentation, but the reality is more complicated. In real applications there are a lot of data sources. Some provide you data upfront, some lazy load. With Collections API, you need to construct these items as JavaScript objects before rendering. In practice, developers always write functions and hooks to construct these objects instead of encapsulating logic in React components. This doesn't sound like the React way. Semantic UI React was developed when React was still at version 15. There was no easy way to communicate between a host component and its child items. It was the only possible solution at the time, but now the React ecosystem is different, and in Stardust UI React, we started to explore alternatives to the Collections API. The most obvious and natural way: use JSX markup to define items. With the new APIs introduced in React 16, this approach was now possible. So when we were discussing possible options for Fluent UI React v9, we went with JSX children instead of collections, based on developers' feedback. I mentioned React context, but it has a small problem. By default, React propagates all updates to all context consumers. Once something in a menu item state changes, all menu items will be rendered. Doesn't sound great for performance at all. There is an RFC that proposes useContextSelector hook in React. The idea is that it will behave identically to the useContext hook, but with a second argument, which is a selector function to compute a resulting value. However, this feature is an experiment in the early stages, and it's hard to say when it will be shipped. There is good news. There is a package called useContextSelector that implements the hook in user-end, and it's even compatible with concurrent mode in React. With this approach, our menus will only render items that change their active state. Another benefit of shorthand collections is that you know all props you need to render items in advance. With JSX children, we don't have this benefit anymore. React provides React Children API to manipulate them. However, this API introduces a lot of restrictions to the composition of components. The problem can be described as you don't know your children. In React, components can be wrapped. For example, a menu item can be used inside a custom menu item that can have completely different props. The caveat there is that the menu component doesn't know what children it will get and how to handle them. Of course, types of child elements can be restricted, but then one of the composition patterns of React is broken, and it's a problem. Another thing to consider with this approach are React fragments. that can be used in markup. Here you can see two snippets that will produce completely identical DOM, but the React tree will be different. As a result, the host component will see a single fragment instead of items. Well, we can be smart developers, right? So instead of just reading props from children, we can traverse a React tree. We also know about React's internals, so this is possible to some extent. But this is not robust at all. Someone can simply combine the previous patterns and group menu items to a component called custom menu group. In the React tree we will see that component, but since it doesn't have children, there is no way to access them during render time. This is expected, because React renders from top to bottom. With JSX children, we are limited with patterns. But we can transfer data from top to down using React context. Since our components can be controlled, we need to build a connection between the host component and its children. A good example here is accordion and accordion items. The host component has opened item prop, and children have a value prop that identifies them and is unique in that collection. In the most cases, we prefer to use JSX children to declare items, and now you know why. However, we might want to reevaluate and reconsider some of decisions in v9, because in certain cases even the best patterns may not work. For example, JSX children might not be a right choice for a tree component, as it has nested structure of items and it doesn't play well with virtualization.
We have just talked a lot about how you can't parse React children. With our trigger API, we try to set some rules so that we can add some control to what the children might be. But again, let's start with some well-needed context. Let us take tooltip component as an example. Tooltips should be attached to an existing element that they describe. It's quite easy to design an API around the content and the style of the tooltip itself. But the important question is, how can you attach it to an element? For the tooltip to function correctly, it must be positioned relative to the correct element. The element also needs to be able to open and close the tooltip based on complex interactions. Let's not forget about accessible markup, so that the screen reader users can know the information in the tooltip. We take care of these concerns so that there will not be extra work for the consumer. You will get to know how much Microsoft cares about accessibility in a future episode, but let us say for now that we would like to design Fluent UI so that the developers can have the right thing out of the box. As with most concepts, triggers also involve the journey from Semantic UI React to Fluent UI React. While the idea is the same, API looks different. In Semantic UI React, children renders pop-up content, and trigger is a prop. This approach feels natural until we need to handle composition. For example, we can't have a tooltip and a popover on the same button. And this is one of the problems solved in Stardust and Fluent UI React v9. In Stardust UI React, we did not have an opportunity to change things a lot, because like previously, APIs in React that are common today were not implemented at that time. But we made children renders trigger, and to pass your content, you need to use content slot. With this change, the same scenario with composition looks more meaningful. The adoption of the trigger API in v9 was driven by the same motivation as with shorthand collections. Everything's more obvious with just JSX, right? Another issue that we wanted to solve was to make the API contract more obvious and understandable from JSX markup. This is how Fluent UI React v9 got new triggers API. It consists of a host component, for example popover, a utility component that wraps around trigger called popover trigger. They don't add or modify anything in DOM. We use React clone element API to enhance the existing element with event listeners and attributes. It's worth noting that v9 popover trigger can only be first child of popover. Since we cannot parse React children, we set up this convention in the trigger pattern. The actual content is added by popover surface, which renders out of DOM order using React Portal. The single exception in v9 is tooltip component. It follows the approach from Stardust UI. The motivation was to make it less verbose, since most common use cases would simply involve a short text. The trigger pattern also makes composition more intuitive, and JSX markup reflects how DOM would look like. The trigger pattern is powerful, but its children must be spreading props and forwarding refs to accept event listeners and attributes. Having such requirement everywhere in the library would be crazy. But as we don't want to have additional DOM elements, we can rely only on React clone element and accept the consequences that we discussed previously.
We covered the foundational APIs used in Fluent UI React v9 to explain their design and what's under the hood. However, we didn't talk much about how they actually work. To get more details, please check our docs. The most important lesson there is that these APIs didn't appear from nowhere. They were created and evolved based on consumers' feedback. That's all for now. Subscribe to not miss out new episodes, and see you next time.
Fluent UI v9, we think.
To get more details, please check out our docs.
Tooltips should be attached to